Welcome to episode 2 of The Duchess
and the Doctor,
where we answer real questions from real people about eventing. Let's dive right in. On community Slack, ZT asks, I am looking into understanding the internals of the suppress function on Kafka Streams. What a great question.
It is. Suppress is very interesting and very unique.
I'm glad you're not going to suppress any information, right?
No, I'm not.
We're going to give away all the details?
All the details.
All right, let's do it.
First of all, suppress is actually a very good pickup from our last episode where we talked about windowing.
Yes.
Because it is related to windowing. Even if not only to windowing, you can only suppress a non-window table, but it's actually also fun. So the question is really about what is the internals of suppress. And it also asked if there is if it's actually in memory or if it's not in memory.
Well, it is in memory.
Yes.
I answered the question. Do I win?
Well, but you still suppress information.
Continue, give us more.
Yeah. So suppress is built in memory. We never did a RocksDB implementation because performance was very bad. That was actually part of the original kit. But in the meantime, we have a different implementation that is RocksDB-based, but it's not suppress anymore. There's this new thing, what we call an Emit strategy. And this is now part of the windowing API, actually. So when you say window by, then you can add an Emit strategy.
How many Emit strategies are there?
2.
For now.
Yeah, but it's also a little bit limiting. And so Emit strategy is now also tied to windowing, while suppress, as I said, is also for non-window tables. So you can mix it up. It's more flexible.
You let that fly?
What do you mean?
Seems a bit like, dichotomy, like you let suppress go into the windowing API. I'm just surprised.
Yeah, I mean, in the end, what do you really want to do? I mean, for windowing is okay because that is a very common use case, right?
Yes, it is.
Yeah.
But not the only use case.
No, it's the only use case. That's true. So we do have those 2 strategies. So one is the default strategy is emit on change. That is what Kafka Streams does all the time. And then the other one is the most popular one that is emit on close. When the window actually closes, you get one final result. So this strategy is based on RocksDB if you pick it. Of course, if you store it in memory, everything is in memory again. But so this is piggybacked and it's tightly coupled. And suppress is an in-memory implementation. And suppress is slightly different because, as I said, it's basically an operator that you put after the computation. And so what it also allows you to do is not just for windowing to say emit on window close, what is a suppress strategy. The default is again emit every change. But the interesting part is really that you can also say, because the buffer is in memory, right?
Dun, dun.
Danger.
Dun, dun.
You could say, well, I'm okay to actually emit intermediate results, so it's not like strict, if you run out of buffer space.
That's correct.
And so for, of course, the emit strategy, we don't need that because everything is on this. The interesting part is also that for suppress, you actually get 2 stores now. You have original RocksDB, and you have your in-memory buffer that is downstream. For the emit strategy, we don't do that. We basically merge it into the aggregation function itself, where you basically just have your RocksDB store.
Yep.
And now the implementation just changes, how hard can it be, to basically say, well, instead of doing the regular thing, we update the aggregation result and we emit downstream, and then the downstream suppress could do its job. We just say, no, if the emit strategy is emit on final, we just update RocksDB, we don't send anything downstream.
Correct.
And then later on, when the window actually closes, then we can send the final result after the fact.
Right. Very event-driven. The event is the window closing. And I think, I personally prefer knowing anytime something changes. I love it. So I'm a fan of the default emit on change.
Yeah.
I am a fan of that. However, not all systems work that way. So we added suppress in Kafka Streams later on because, as you might imagine, there were some use cases where it wasn't ideal to get hundreds of thousands of window emissions when really they really cared about the end one. So that's like behind the scenes, why people want to suppress.
Yeah.
But there are other systems that the default is flipped.
Yes.
Apache Flink is one of those, is it not?
Yeah, absolutely. Because in Apache Flink, everything is Watermark-based. And if you use a Watermark-based system, then you basically say, well, I basically make, to be a little bit offensive, like micro-batching progress with every watermark that comes in. I know, that is mean.
The imps are staring at us right now.
Oh, I bet.
Dagger.
Yeah.
Hi, guys.
And I'm not saying Flink is micro-batching, right? Don't get me wrong, it's not, absolutely not. But you have this more like the watermark is more like a step function, right? So it drives your computation. By default, Flink, if you set a window, basically says, well, I wait for the watermark, and the watermark tells me when I can close the window, and there's no intermediate results by default.
Right, absolutely. Now, that's not to say that you couldn't get intermediate results in Flink.
Yes.
You can. There's ways to do it, I've been told. And I think you really need to think about that when we look at our use, like your use case. And a lot of times what we find is the use cases where you really don't want to emit till final, those are use cases where we're trying to do something like an average. We're trying to, like, you know, whether it's collecting IoT stuff, right, from, like, you know, the radio in your car, whether it's something where the data as a whole, like, until it's aggregated, it's really not even worth it downstream. So that's not for something like invoices, or fraud detection, or payments, and although it could be for fraud detection in some cases for pattern matching, but not those really, you know, what I like to call beautiful mission critical eventing. You usually don't see as much of that type of only emit, right, on final in there. So I think, you know, that's a very, very cool explanation.
Yeah.
And check out suppress in any system, or just use, you know, like Flink will do it by default.
Yeah. The other interesting part I want to add here is, so we talked about the different window types, especially sliding window and hopping window last time. And yeah, exactly. And this actually reverses the pattern a little bit, because for the actual real sliding window, I think intermediate results don't actually make sense now.
Yeah.
Because you're looking to the past. So for a sliding window, you actually always want to have emit final. I mean, you can do it the other way around to have, like, you know, intermediate results, but it kind of semantically doesn't make sense. While for, like, a daily window, it makes totally sense to say, well, I want to have the intermediate result for every update I get in, because while the aggregation is building up, you know, I get the intermediate results because I'm interested in the business, what is happening today, and I don't want to wait 24 hours until the window closes.
Well, and I would also say the following. If you've ever wondered, is something working? It's really nice to be able to go, oh, 1 event, 2 events, 3 events, 4. So just like when you're sitting in your IDE, I find that very comforting. As long as you set catch, max byte, buffer to 0. Always do that too. Otherwise, it might hide intermediate results.
Yeah, absolutely. So the batching that we do in Kafka Streams is there for performance reasons, but for those things, you want to disable it, also for testing.
Yeah. Well, you know, I like to see everything. Everything.
And she does.
Yes. What am I, the Iosauron on Slack?
Yeah.
Is that right? I'm the Iosauron.
Yeah.
That was a great question.
It was, yeah.
I enjoyed that. And now we have another question. This is from someone who is near and dear to our heart, Nick.
Our friend and colleague.
We know him very well. Hi,
Hello,
Nick.
Singapore.
Hello. He asked for more information about, you know, blue-green deployments.
Ooh, fun.
Indeed. And just to preface this, anytime, you know, microservices, when they rolled out, blue-green deployments were very popular. I mean, pretty much every stack you deploy a microservice to, right? There's, like, you know, hot, cold. I can deploy them both. Take one down, leave this one up. They were also stateless, which means they don't care if they die. No, boring. What a snooze fest. We like state.
I also hate state. State is complicated.
Really? It's the most interesting thing, though.
It is interesting, but it's complicated.
Who wants a boring life? I choose no.
That's okay.
So state. Once you start to get stateful microservices, and once you start to look at, like, how do I store state durably, redeployments and changes to Kafka Streams and microservices can get complex. Matthias, we were talking about this earlier. There a recent example where someone had asked a question, changing window type, right? Right? Like, well, what? Can you explain that face? I know what it means.
I mean, that's kind of hot potato. Don't do that.
Right, but why?
Well, because it breaks everything.
And why?
Well, I mean, first of all, it's a semantic question, right? If you say you have, let's say, daily windows, and you suddenly say, I want to have a sliding window. I mean, where do you have the cutoff points? That's the one thing. When you transit from one window type to the other window type, then the point is, how is the data actually stored physically? For example, for hopping windows or for time windows, we do this optimization to only store the start timestamp, but not the end timestamp, things like that. So that can break the serialization format. Also, the problem is all the events that you have already processed, they're already categorized in certain windows, right? You cannot take them out and put it to different windows, because usually you actually don't even store them. We store the intermediate results, so we don't have those anymore. And then, of course, also window boundary changes, and everything just gets messed up. Of course, over time, it would resolve itself, because the old windows eventually expire, and all the new data only flows in the new beautiful windows. But during this time, everything is a hot mess.
Yes. It's messy in the middle, right? Eventually, so when you look at like the cleanest way, like me personally, I love a broadcast pattern.
Yep.
I absolutely love a broadcast pattern. And what that means is instead of like changing your existing stream, right? You got a main stream coming in, you just set a bunch of child streams to it. So for a while, right, I might be getting, I might be pointing to 2 topics, right, as my output. So maybe I want to go, we said, from hopping to sliding window. Well, I create another stream, like a child stream from my main stream. And for a matter of time, and this is kind of blue-green deployments, right, I might have both results coming out into separate topics. And then I can decide when to cut over. And as soon as I cut over, if I want to, I can go back and get rid of the old stream, right? So you got to be clever about this kind of thing, because I think you're right, and it comes down to eventing is always on.
Yeah.
It's never off. Like there's no safe time to say, oh, take a break, right? And so you have to think about, how do I do this in real time?
I think the interesting question is really how you do this broadcasting, right? Mm-hmm. Because in the end you could say, well, I have a single input topic, mm-hmm. and I have like then 2 independent applications reading from it, and you broadcast into it, right?
Yeah.
But you could also say, because then both of them get the full volume of data, right? And very often in blue-green deployments, you actually fail over gracefully. Mm-hmm. They basically say, I redirect a certain amount of traffic to the new feature, right? Mm-hmm. But then, of course, you need to change the pattern. You need 2 input topics, and you need to change further upstream. Where you say, I wrote a certain amount of top data into one topic, mm-hmm. and another amount of data into the other topic, and then those 2 topologies read from different topics, and they get a different amount of traffic, and then you can slowly move traffic over until you see the new application is actually doing what it's supposed to do.
Yeah, and then there's version deployments. So what we see a lot is where people will roll out, like they'll actually change their application ID and roll out a brand new version with all new topics, right? There's a lot of overhead there, but it's the other way to kind of do what you said, Matthias. You can keep them running at the same time. You can verify your results. You can cut over slowly. You can have a drop dead date. And then I've also seen people even event drive that, where somebody will publish an event saying a new version, this version has just been released of this new application. A consumer who is consuming, right, will consume that and then change the topic that it's listening to, right? Because we can do dynamic topics. So there's ways that you can kind of make that automated. Usually I always say don't automate too early, but if you know that this is going to be a rapidly changing and you really want to make it seamless and good, then this I would think is, like, to me at least, is an automation that you should absolutely look into. Here's another question for you. One of the things that I get often too is, how come I can't redeploy my K-Streams app? All I did was add a new topic. I have to shut everything down?
Yeah, you have.
In Pivotal Cloud Foundry?
Yeah, that's you could call it a limitation of Kafka Streams, because in a regular consumer application, you could totally do that. Mm-hmm. The consumer is smart enough. The problem in Kafka Streams is that we assume that every instance reads from the same topics. So if you add a new topic or you remove a topic, you get kind of a problem, because there's a probability that you bounce your first instance, and let's say you add a new topic. Mm-hmm. So this new instance now subscribes to a new topic. So far, so good. But now we basically give one of those partitions to one of the old instances, because we assume everybody's subscribing to the same thing. And now the old instance basically says, hey, I get data from a topic I never subscribed to, and it falls over. And similar,
I don't know you.
Exactly. I don't know you. I don't know you.
I'm so sorry to this man.
Yeah. And it could also happen the other way around, right? If you remove a topic, then the new instance could still get a partition from a topic it doesn't subscribe any longer, and then it again falls over.
Yes.
But usually for Kafka Streams, you assume that, and we have to make certain assumptions. I mean, we could be a little bit more flexible maybe, but it's just more difficult to do than in the plain consumer, because in the plain consumer, we don't make any assumptions what the application does. Yeah. So it's totally up to you to handle those, corner cases and race conditions.
Well, and I think you said it best. One of them is like your ability to fail over, your resiliency. If you assume that you've got, let's say, 10 instances of an application running, and at any point in time, the workloads can be moved to another instance of those applications running, how do you do that if you've got 2 different topologies, right? Like all of a sudden your assumptions are blasted, they're blown. And then scaling. The reason we also do that is because it's super nice. Like nobody has to worry about stuff like that in K-Streams. You spin up another instance and K-Streams figures out how to share the load. #1team. And so I think those restrictions are there for good reasons, but they certainly are puzzling, and I think definitely worth talking about.
Yeah, absolutely. And I mean, if you look into, we also talk about streaming in general as other systems. I mean, let's say Apache Flink, right? Mm-hmm. In Apache Flink, you can make those changes, but internally Flink also brings down the whole job and then redeploys the new jobs. There's not really like a rolling bounds upgrade, so Flink doesn't have the problem that we face. because in the end, you take a snapshot, then you shut down everything, and then you resume from the snapshot.
Correct. Well, and you could take, what are they now? Incremental snapshots, right? Those are
Sure.
But they, that only supports some changes, right? Not all of them can be made with incremental snapshots. And I think you're hitting on the right point, is that each system, whether it's a microservice type function or it's a processing cluster, has to deal with these issues.
Yeah, exactly.
And I think this hits more people because of the way microservices are typically thought about. They're stateless, kill them, nobody cares, they don't have to talk to each other. Untrue in K-Stream land. And so when people are first starting out with this, they run into a lot of problems trying to deploy it as a typical microservice, right? And I think it was an excellent question. Very good question, Nick. Hi to Nick again.
Yeah, and it goes back to my statement about state, right? I mean, I love state. State makes it powerful, but I also hate state because it makes it complicated. And I like these discussions about, like, state being here or there. There's also discussions about remote state and whatever, but it just shifts the problem somewhere else. It's all a question of trade-offs.
Yes.
And there's just a set of solutions you can pick from, and those different systems pick different solutions. Yeah. But it doesn't mean the one system is better than the other. It's just like, maybe for your particular use case, this trade-off is better, but for the other use case, the other trade-off is better, and so then you need to pick. And ideally, of course, the system has many trade-offs built in, so you can use it for a broad set of, but very often it's just architecturally not possible to support everything.
Yeah, well, and I think, people ask me a lot of times, they say, like, K-Streams is tied to Kafka partitions, which is wonderful for many reasons, and also not so wonderful for many reasons, right? Two sides of a coin. So you really need to look at, do I get bigger advantages by just using Kafka's built-in resiliency, right? The built-in group coordination, right? I've got my durable storage right there, right? It's retained in a changelog topic. Or is it better for me to take that outside of the Kafka world and use something like a Flink, right? So I think, it's an excellent question.
And it goes back to the blue-green deployment problem, right? Mm-hmm. If you move the state out of the equation, so for your actual applications that you're deploying, it becomes more easy to basically switch it out, to do the rolling bounds. On the other hand, if you really change the state, what we just discussed about, like, changing the window type, it doesn't really help you because it's still in the state. The problem doesn't go away, right?
Yes.
So again, it can solve some problems, but not all problems. It really depends, what you do.
That's right. Well, we'd like to thank you for joining us on episode 2 of the Duchess
and the Doctor show.
Nice.